are the Water Wizards. It's my privilege to present to you tonight the athletic circuit. It really is a privilege to be in front of all you all. Thank you, Dr. Peoples, Dr. Hayne, all the professors being here. I actually don't know most of you, which is exciting because I'm used to seeing faces I know every day. So I'm really excited to present tonight. My name is Mark Sternary, as was mentioned. I am actually not going to be doing much with engineering in the next 4 to 8 years. I'm going into the Army as an infantry officer. We're just going to present introduce ourselves.
My name is Darius Jackson. I'm from Florence, South Carolina. I also plan on going to the military.
I'm Joshua Bateman. After graduation, I'm going to go work for Optimum Controls Corporation in Reading, Pennsylvania, and be an electrical design engineer.
I'm Colin Su. I'm from Taiwan. It's also Taiwanese Air Force.
Alright, so as you can see, we have a lot of different backgrounds. We came together, and I think we really had fun this year working together and coming up with a product. So, what do we do? We're going to cover our agenda first.
We're going to introduce you to our project, what we did. We're going to tell you, give you a basic overview of how it works, and we're going to take a little deeper look into our system components, and then we're going to break it up into each module, the resistor module and the capacitor module. And then we're going to tell you what happened.
So, introduction. Athletic circuit. Athletic circuit is designed to provide a visual representation of, first off, electricity flow and electrons.
And then we're going to tell you how our model represents the V equals IR relationship inside the circuit.
And how a capacitor operates. It's basically like a battery, but a battery makes its own electrons, while a capacitor holds it and carries it, and allows it to charge other components.
Exactly. So pretty much what we had, the challenge that we faced was we were thinking about maybe freshman and sophomore level engineering classes. How do you picture a circuit, a resistor, a capacitor? And a lot of professors had always used the example, imagine water flowing through a pipe. So we kind of took that analogy one step further, and we pretty much made water flowing through a pipe turn into resistors and capacitors. Alright, so Josh, go ahead.
Alright, how it works. We separated both the resistor and capacitor modules. We thought it would be easier to make a teaching aid that way. So for the resistor, we decided to go with representing current with fluid dynamic property of centimeters cubed per second, which is water flow. And we related that to coulombs per second, which is amperes. And for the capacitor, we chose, we have a large storage tank as the battery. And the battery holds about 24.5 pounds force of water, and so we call that a voltage. And then we use filters to represent the resistance, and they're dependent on the length. The longer the pipe for the resistor, the more filter material that is inside. And then we have a water reservoir for the capacitor, and that has the ability to store water as charge. So the capacitor fills up and empties as normal capacitor, except water is just electrons. And then we have servo control ball valves, which can act as switches by opening or closing them. They can also act as variable resistance.
Alright, now Sue's going to talk to us a little bit about all the components of it.
So here's our physical components. So we have the 6-inch diameter and with a 2 feet tall PVC pipe, which can hold like 24.5 pounds of water. So we just treat it as like 24-voltage power supply. And as you can see in the picture of the middle, here's our switch, which is the ball valve controlled by the servo motor. And we use Blue, the servo motor controller, to control it on and off. But and also we can use it as a variable resistor, so we can from all the way closed, which will be an open circuit, and all the way open will be a short circuit. And here's our different, different set of the resistor, which we fill it with the filter materials. We can restrict the water, which those just serve as a regular resistor will restrict the current. And the picture on the left is flow meters. This can detect the flow rate and give us the DC poles and also the frequency of it. So as the flow rate going up, the frequency is also going up. So we use that to detect the change effect of the current effect by the resistors. and particularly middle of the capacitor, which is can hold all the waters, and with the water level sensors can sense it how full the charge is. And this is a component like we connect to this with the power supply and connect to that position. We can read the multi-different effect by the charge of the water. So then we'll connect that to the computer, and then you can read from the screen and say, okay, how much charge is before charge. And also you can see the charge line will be different versus like the resistor we connect before and after, and affect the time that the charge and discharge.
Exactly. And the capacitor module is kind of cool because that the water level sensor, it's like a 1 foot long tape that looks like a white tape. It actually uses capacitance to determine how tall the water was. So it's kind of funny that our analogy was this reservoir is a capacitor, and actually the tape uses capacitance to measure how tall the water is. So it's kind of interesting. Side note. All right, Josh is now going to talk to us a little bit about the resistor module.
Despite resistance students, we decided to go with 3 parallel resistors, and each of these represents one of those wall valve switches or a variable resistor. And the flow meter would act as an ammeter and measure the output current that comes into the entire circuit. And so we have an on-off valve to turn on the whole system, and it'll run through the flow meter telling us how much current we get. And as we turn off each valve, or turn it on, we can add or take away resistance from the circuit. And we can have multiple ways of showing how V equals IR, and give the students different ways of looking at how to do circuit analysis.
Yeah, so I kind of have an easier way to describe this. This is kind of the actual components that we made. So as you can see right here, this is our standpipe. It's painted black. It has the word battery written on it. So that's the battery. And then you can see there's the 4 ball valves. So they're the things in black, the yellow handles. They've got these kind of weird black things. Those are the servo motors mounted on each of them. So that was a bit of a mechanical issue. And we'll talk about that later on, one of the issues that we faced. So this is just looking at the device itself. Over here we have the computer screen, and this is a blow up of the preliminary interface. So what you got there is you have those little sliders. They've got little green dots on them. Each one of those controls one of those valves. So all the way to the right would be all the way closed, all the way to the left would be all the way open. So as you slide, you open up the first one, let the water flow, and then the second one, the third one, the fourth one, and so on. To like Josh was saying, you add one in parallel with the other one to see a resulting change in resistance. I'm just going to talk a little bit about the flow water, the water flow sensor. So that was probably one of the, it's a 1/4 inch water flow resistor, and we had all 1 inch pipes. So as you can see, we had to neck it down, which affected our results in the end. But pretty much what that does is it outputs there's a little water wheel in there. As the water wheel spins around, it outputs a square wave. The square wave has a certain frequency depending on how fast it's spinning. So when all the valves are open, it spins the fastest. That's the most current it can draw. When all the valves are closed, it stops spinning. Frequency is 0. So that's kind of the analogy we use there. Brings us to the capacitor module.
It is capacitor. So we connect that the battery. So we connect that with the on and off valve. And before the capacitor, we put it together with a resistor. Also, before and after we put it together a resistor, and what the resistor would do affect the charging time. We'll show you an equation a bit how it affects the charging time, how the exponential way will show. But that was affect the time. So when open up that one, so they'll start charging up. Then we have that position to read the water level, and then we have a computer with the LabVIEW program that can show us how to charge in the way. And also we'll have the light saying, okay, here's fully charged, and have a count and say, okay, how long has it been charging up? And after that, you can just tell from the graph, and also they'll also show you how the time, so you can use the time to see what's the resistor or what's the capacity value of it.
Yep.
And this is the visual aid that we use. Like we said earlier, we had a clear container that we filled up with water that acts as our electrons. It filled up. It takes, like you can't see right now, but in the early picture you did see, it measures how high it goes, which sends the voltage to the DAC, which goes to the computer. On the computer we use a program called LabVIEW that showed us the graph that we just explained. It shows how it charges and discharges. And the yellow, black is the ball valve that we use for opening it. And this is the LabVIEW program we use. It's simpler than any other language. It uses pictures, so that always works and helps. But we use a couple of shift registers to send the data back and forth, and after this we were able to get a graph that shows the charging and discharging.
I'm sorry, do it. All right, so I mentioned earlier that the challenges faced along the way. And yeah, so one of the big ones was figuring out the best way to display to a student how these things work out. And so this has never really been done before. A lot of people have tried different ways. Our method of using water hadn't really been clearly fleshed out. So we were kind of, left with the challenge, exciting challenge of figuring out a way to do this. And then we just didn't want this to become a mechanical issue. That was something we talked a lot with Dr. Peoples about. We just didn't want to overcome a mechanical or plumbing problem, essentially. We wanted to actually be able to electronically control this. And that turned into working with the ball valves and figuring out how to get a ball valve to decrease the tension so you can actually use a relatively low-cost servo motor with it.
And this is the results that we got from the capacitor, which is almost looks like what you would get from a real capacitor. So our design actually worked. The tape measurement read the data. It changed into a voltage, which you can see is against the voltage that it received. And just like this, can be an aid for students in the future.
All right, so application. Jackson was just talking about how it can be an aid for students. Well, that's kind of what we're hoping this is able to be used for. Professors are going to be able to use this to demonstrate to pre-knobs when they come in. We've always got like middle schoolers or high schoolers coming around to see our see the engineering department. Well, this would be something really cool to be able to show them, and also to parents. Look, this is something that we have just kind of sitting here. We're willing to be able to reach out to your students if they have a problem or help them visually understand something a little better if they need it. All right, so in conclusion, what did we talk about? We talked about LabVIEW. We use LabVIEW and Pololu interfaces to, as the visual side of our project. We use pumps to keep the system cyclic. So that was the exciting thing about the resistor was you could just kind of turn on the pump and start messing with the valves, and you wouldn't have to keep adding water to it because we had almost no leaking and an equal balance of water in the pipes. And our project demonstrated the basic function of capacitor and resistor. All right, now Josh is going to go over what we just covered.
So we introduced you to our project and our main goals to reach out to the students. They can interact with the Pololu interface after the professor demonstrates it so then the students know how it works. We told you how it works, all the components that went into it. We talked about each module and what it does and how it conveys to the students the topic and the information that's being taught. And we told you about the results and how it actually came out to work as we expected. Any questions?
All right, well, that's all we got. Thanks, guys.